Okay, so I will assume that everything is fine. Good morning to everyone. My name is Dimitris. I am working with the development team for HyperMesh. And today I will be presenting our connectors technology for the Aerospace Coffee Break series. I'm really glad that I'm here. Really happy to be part of this series. And today I will be your presenter. And let's try to do a dive into our how our connector workflows affect the aerospace specific or aerospace related use cases. Okay, let me go into my presentation mode. So for our aerospace specific realizations, in HyperMesh we support hoof-based realizations. If you're using OptiStructure Nastran, we support spring rigid type of realization, CFast general. And if you're using Abacus, we support fastener nor coincident. All of these types and all the attributes for these types can be tuned from the control manager, as I will be showing later in a live session in HyperMesh. But as you can see, the images that are attached in the slide, we can tune all the attributes and all the coefficients that we need in order to define our formulas. Let me jump out of my presentation for a moment. Okay, I see no issues in the chat, so I suppose that you can see the presentation. Okay, so if you want to quickly see in a demo how this looks, we have 12,000 spot or point connectors in our session. We can define our control. In this case, we're going with a rigid spring type of realization. We can define that we want to use our hoof method. We can define our diameter. We can define our material. We have flexibility for that. We can either define our elastic modulus manually, or we can use a material that's already in session. We can also define all the rotational stiffnesses. And even if we wanted to, we can do a user-defined, which allows us to define the parameters, say B1 and B2. In this demo, we'll go with just the automated version of it. And after everything looks good in our control, we can realize our connectors. This is in real time. So we have 12,000 point connectors. So it will take a few seconds. On the bottom left, we can see the percentage of completion. It should be almost ready. And after the realization is done, we can visit our connector browser. And from the connector browser, we can inspect all the connectors that have been created, isolate one, for example, and get a closer look to see how this looks. We not only support hoof-based realization, we also support our high-look realization, which used to work with PostScript, which has now been removed. And this removal has resulted in a significant performance improvement. Everything else in the definition has remained unchanged. And the method used for this realization is the Ratman method, which is also a realization that can be tuned from the connector control manager. Also, we have an attachment type that replaces the stack node tool. As you can see in the second image, we can define an attachment that realizes a rigid spider with an element type of RB3 stack node, and it is using a projection feature to realize the attachment. Since those aerospace-specific realizations use stiffness formulations, as we have just mentioned, it is very important to note that in our preferences, we have some options to automatically define how the state will react to the physical changes and the calculation changes we are doing to our links. So the Booth or the Ratman formulations depend on the properties of the links. So if something changes, we would have to automatically update our connectors to redo the calculations for those formulas. So instead of doing it manually, we can visit our preferences, and from the calculation changes, we can change the nothing option, which is the default option, which means that the connectors will not do anything when we change something, to the either modified, unrealized, realize, which will automatically do whichever the option states. And also we can set it to update, which is very important, especially for since we're talking about aerospace applications. We can set it to update that will redo all the property calculations without changing the internal IDs, which is very important for aerospace applications, which I know that have very high demand and are very strict when it comes to ID management. So I would highly suggest you visit this preferences section and play around a little bit with those options. Set your calculation changes to update or to realize, and play around a little bit, see how it helps you, which combinations works better for you. And if you wanted to have a look on how that actually behaves, we can watch this short demo. We have our high-loc and our spring rigid types. And we set our calculation changes to modified. Now, if we change the attribute of the property of one of our links, you can see that the connector is automatically modified. And if we change it to unrealize, again, when changing the thickness of the links, it will automatically unrealize. And of course, we can realize again manually. Same thing, if we change it to realize, it will automatically realize the connectors. And if we set it to update, it will automatically redo all the calculations. And the connectors are ready to go. Okay, so that's it. Those are the main points I wanted to make with the short presentation. Now let's dive into a live session in HyperMesh and see how this looks. Okay, so I have a very simplified model here, and let's say that a structural analyst would want to model all the connections between those structural members, and that analyst has their model, and let's assume that all the elements are in place for all the members, and the mesh looks good, and we're all happy with it, and all that's left is the connections. So all we have to do is visit our connector control manager, which is located in the connectors ribbon, and we can decide which type of connection we want to use. For my demo, I will use a point connector. So I right-click, create, and then I pick one of those types that I have mentioned before that are related to an aerospace use case. So for example, I can use, let's see, a CFast general, and then I can scroll down a little bit and define my hoof type. I can select the material I want to use. Doesn't have to make sense for now. I will use a dummy material I have in my model. The flexibility here is that we can use either a material from the model or from a file, or even specify the elastic modules ourselves. And everything else is tunable. The rotational stiffnesses are tunable. The material itself, we can expand the material option here and define everything else that needs to be defined. And we can even inspect our coefficients based on the material connections. And again, as we have showed earlier, we can do a user-defined hoof, and this gives us the option to define the coefficients A, B1, and B2 ourselves. That's very useful. The user can choose each of these options based on their preferences. Okay, so now that I have my controller ready, all I have to do is use what the design team has provided me with in order to create the connection. So there are different ways the design team can provide the analyst with the representation of the connection. It can either be a full 3D geometric representation of a fastener, as I have done a mock-up here. This is a very simplified version of, just for the sake of our conversation. Let's say that we have a 3D solid that represents the fastener, or we could even have a 1D representation of our fastener by using lines. I believe this is common in aerospace applications. And it is the analyst's now responsibility to use this information to realize the connection. And in HyperMesh, we provide options to do that for almost every geometric information that we have in session. So if we open our point connector guidebar, we can see that we can use FE entities, this means nodes, but we can also use geometric entities like points, lines, arrow lines, which I will get into in a few minutes. We can also use solids and locations. So for us, it doesn't matter right now what the representation of the connection is as it comes from the design team, from the CAD software. For example, now I can use solids. I can select my solid, and you will see that the connector is created in the middle of that solid. And if I go to my connector browser and go to points, I can see that the links are in place. I have a tolerance, which I can tune. For example, I don't want it to be 10, I might want it to be 20. I can inspect that my projection is not what I want it to be. I just want this bottom projection. So I can decrease the tolerance a little bit, but to 10 should be good. The projection looks good now. And I can select my control. This is the control that I have defined earlier. And I can also access it from the guide bar. Again, and I can do everything I want in here. I could rename it even. Let's rename it to CFast just to recognize it easier. And now I can realize the connector. Now, if I hide my solid, I can see that the connector is successfully realized and the finite element is also in place. So connectors support creation of solids. this is a very useful feature, I would say. And this is not only for point connectors, but also fasteners, support creation from solids, also lines. For example, if you wanted to model a seam weld, you could use a solid that represents the actual weld, and the connectors will automatically extract the midline of that solid to create the connector entity. Okay, so for our first example, we are good to go. And now let's see another example related to aerospace that we support, and I have mentioned it earlier. Let's say that we have 1D lines to work with. And what we can do is, instead of just picking lines, we can pick aero lines. And what this does is that when we have our lines, we have the body of the line that represents the actual body of the fastener, but we also have an extension of that line. And that extension represents the diameter of our connection. So what we can do is we can select both lines, and we can see that the connector is created in the middle. We can also inspect that the links are correct in our connector browser. And if we go to our entity editor, we can see that the diameter is not 1, as it is by default in our control, but it is 2.74. This means that if I realize the connector, and I select this line and measure it, it means that the diameter that is used in our definition, it is the length of the line that's representing our fastener. Okay. So let me hide the solids again. We don't need those. Okay, so we see that in HyperMesh, it doesn't matter what type of geometric entity we can use. We can go from full 3D geometric representation of fastener to a 1D representation and only intermediate versions. It's up to the user to select and decide what type of geometric entity they want to use. We can do all the different options from the selection in the guidebook. Okay. So I see no reactions to the chat. I believe we're all good. And I believe in this audience there are some novice users, but I would like to believe that there are some more experienced users as well. And I know that in this series there are previous videos, at least one previous video related to connectors. If you haven't watched that video, I highly recommend you visit our page and watching it. It is very insightful. It will get you started with connectors very fast, on the basics on how to create connectors, how to define some controls. But I would like to spend some time to show you how you can elevate your connector workflows by combining the connector workflows with the part workflows. I highly suggest, if you haven't seen a tutorial about parts and the part browser, I highly suggest you visit our site again and watch those tutorials. Those are very insightful. And as you can see, in my model, I have parts that represent all of my structural members and also my connections. So let me start fresh and delete my connectors and the finite elements they have realized, and say that I want to create again my point connectors from my solids. And before I start creating the connectors, I will go into my menu and I will make sure that my organized source part is checked. Now, this is not a part related video. This is not to explain how parts work. But I would like to mention this for the little bit more experienced users and for the novice users, just to trigger some interest into how you can elevate your workflows and how you can automate the creation and realization of connectors. And before I create now my connector, let's investigate a little bit the part browser. You can see that I have my solid fastener part that represents this solid fastener. And I can see that the part has a black mark here that indicates that there are instances of this part in the session. And from my browser, if I hit this dropdown and I do instances, I can review which parts are instances of each other. So instances in HyperMesh means that those parts are identical. So if I now create my connector and I have my option to organize under the source part on, I can create it. And now, if I go again to my part, I can see that this part not only contains the geometric representation of the fastener, but it also contains the connector itself. So if I now right-click and go to instances, I can synchronize it with the rest of the instances in session. And what this does, if we zoom in a little bit, maybe hide the solids, you can see that it has created a second connector for my instance. Now, I have done this for only 2 instances, but imagine if you had tens or hundreds or even thousands of those fasteners in your session, and you wanted to create connectors from those. If you had to do it manually, this would be very time consuming. So now you can just create it on one of those instances and then synchronize them and automatically propagate all the connectors to all the instances automatically. So this will save you tons of clicks and lots of time from manually creating the connectors. All I have to do now is realize it, and it should be good to go. So this is a very brief example of how part workflows and connector workflows working together can create automation for your workflows and how it can save you time. And this is true for almost all of HyperMesh's tools, and which means that if you learn how to combine the workflows, you can truly elevate your use cases and reduce the time you spend on those. Okay, I still see no questions in the chat. That's good. And also, this doesn't mean that we only have to use solids to propagate our connectors to all our instances. We can do it from the 1D representation of the connections as well. All we have to do is use parts and make sure that we have our instances synchronized. Okay, so with that, I believe I will conclude my presentation. I will try to see if there are any questions in the chat. And I will sum up by saying, make sure you check the aerospace related representations, which is spring rigid, CFAS general, fastener non-coincident if you're using Abacus, and our high lock type of connector. And make sure you also visit our calculation changes option in the preferences. This is a very useful option. And when it comes to automating connectors and creating connectors, you can use solids, you can use points, you can use lines, you can use aero lines, and all of those combined can really elevate your workflows. Okay, if there are any questions, I would be more than happy to talk to you in the chat.